Hi, so we are looking at section 2.2, which is about graphing functions or graphs of functions. If you recall in the, I think on the first day of class when we discussed function or when we talked about functions, I mentioned that not every given graph or every graph represents a function. And I think I remember I mentioned the vertical line test. So vertical line test is a key to check whether the given graph or whether the graph represents a function or not. So what does vertical line say? It says that a curve in the coordinate plane is the graph of a function if and only if no vertical line intersects the curve more than once. So more than once means what are the possibilities left? So if it is greater than 1, it is not a function. But if it is 1 or less than 1, which means 1 or 0, so it crosses the function at 0 points, means it does not cross the function, or it crosses the function at 1 point. Then it will be a graph of a function. So in other words, the graph represents a function. So let's check. If we are given some curves, we draw vertical lines through them and we try to see how they behave. So the first example here, so we have this shape. Does anyone know the name of this shape? This is called an ellipse. Okay, anyhow, we don't have to worry about the name at this moment. We are only worried about if it's a function. Now if you can show one line crossing in more than 1 point, that's enough to say that it is not a function. Okay, so in this case you can see that the graph is the red line, vertical line, is crossing it, the graph, in 2 points. So this point and this point. So we can say that the graph is, this is not a function, not a function. The next graph or next curve, if I draw a vertical line, let's say over here, I notice it crosses the graph only one time. Now, do you think there is a place where if we draw a vertical line, it will cross the graph in more than 1 point? No, we don't see that, right? Now, when the graphs are given like this, it's should be understood that they are going on and on and on forever, down, 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 and from here, right inside, it will be going up and up and up like that. So, in which means wherever I draw the vertical line, even like that, far away to the left or far away to the right, it will eventually cross the graph, and only in 1 point. So this is a function, is a function. Let me write it clearly. This is a function. Okay. Next example. Okay, again, this you have to assume that this is going on and on and on. And even if it is restricted, if we have the situation that because you see the axes are like kind of stopping here, so that, by the way, doesn't mean that because we have to cut down somewhere cannot go for infinity. But let's say this is like from here to here, right? So the x values are from whatever this point is to the point where x, this value of x is, and the y values are going to be from here to here. So if we say this is negative a and this is a because it looks symmetric, and then this is negative b and the top one is b, So then again, doesn't matter, but if I draw a line, vertical line somewhere here, so it is not crossing the graph, which we have allowed, right? Which is okay. Still, it can be a function. Now, keep drawing vertical lines in different places, and you will note that nowhere it crosses the graph in more than one point. So anywhere, if it crosses, it will cross only at one point. So this is a function. Okay? So this is a function. Now the last one, we notice that here one line has already been drawn there, and you can see that it is crossing the curve in 3 points. So this is not a function. Okay, so this is how we check whether a given curve is a function or not. Okay, now what we are going to do is review the graphs of basic functions. You must have seen these in the algebra course that you took. I am going to actually show you here how to draw these basic functions using only 3 points. So that's the thing. So we will be using only 3 points. So for each function, we will use 3 points. In order to do that, you must remember, you must know the shape. So the shape should be in your mind. You should be able to connect the equation with the graph and to the name of the function. So the first function, we call it linear function. So the equation is going to look like f of x is equal to mx plus b. Okay. Now you know we have different situations when m is less than 0, m is greater than 0, m is equal to 0. So for the line, you know that 2 points are needed, so which is okay. You can do this one with 2 points, but the others one we will need 3 points. Okay, so a line could be going like this. Actually, I will draw. Oops, I wanted to draw the I wanted to draw the graph with another color. So let's say this line, so this will be the graph when m is greater than 0. And now you can have a graph going like this when m is less than 0. Okay, and then you can have a graph going like this. So this will happen when your m is equal to 0. Okay, that's the linear function. What about the next one? The next one I want to talk about is a y is equal to x squared, which is a quadratic function. So note here, we are now using f of x in place of y because we are mentioning functions. Okay, so the function, how do we graph this one? So I said 3 points. You must remember that the shape is a parabola, like a U kind of shape. So the points you will take, you should do are -1, 0, and 1. Okay, so if you make a table of values, you go like x, y at -1. Now these will be different, could be different in different graphs. it shouldn't be the same, in all the graphs. These points that I'm talking about. So at -1, you get 1. At 0, you get 0. And at 1, you get 1. Okay. So what does the graph look like then? So you should remember the graphs that are symmetric. Okay. So now I will take my in the first case, see, I have not shown the tick marks, but in the other graphs we have to show some, because we are taking points really. Okay, so at -1 the value is 1, at 0 the value is 0, at 1 the value is 0. Now the mistakes that students do is that they will try to join these points, and they will join them like this. I think this was a little off, so I will take my eraser and I will erase this one and move it to over here a little bit. Okay, so what the students do, they will take their ruler or their ID card and they will do this. Join these 2 points, join those 2 points. Is this a U? Really? Is this what the graph of a quadratic look like? No. So that is what you have to remember. You have to remember that it will pass through -1, 1. It will pass through 1, 1, and it will pass through 0, 0, but it has to be curved. So that is the thing you have to remember. So instead of going like that, the graph has to go like smooth. Something like that. That is the graph of a quadratic or x square. Next, cubic. X cube. So again we take the values. So we have x and y. When x is -1, we will get a -1. So it is, when x is 0, we will get a 0. When x is 1, we get a 1. Now we try to graph. Okay. So we have 1, 1, -1, and I'll take -1 here. Okay. No, this is too far away. Okay, I have to come closer to the scale. Should look the same. Okay, -1. So this one, our point is 1, 1, 0, 0, -1, -1. So now what? How do you? So this is something which is going to go like it will. It's kind of look at the only one piece of the quadratic, something like that, but a little bit more to the like that, more sitting on the x-axis near 0. So this is y is equal to x cube, or f of x is equal to x cube. Okay, I don't want to make it too long, so that so this is what you need to know. Okay, the next one is number 4 is the square root graph. Okay, so the next one is square root. So the equation is f of x is equal to square root of x. So you can make a table of values, and now what will happen, remember that our we cannot have negative numbers in the square under the square root. So the minimum value of the graph will be the 0. So the x, y, so at 0 the function is 0, at 1 the value is 1 because square root of 1 is 1. So what should be the third point? So I would suggest that take the value, and you can actually do this trick with any radical function, like for example with the cube root, with the fourth root, with the fifth root, sixth root, eighth root, whatever. Same technique that I'm going to show you here. Okay? And what you should do is you should take the next perfect square. Okay? Next perfect, so next to 1, which will be 4. So we will have at 4 the value is 2. Okay? Now we can take the next one as well. 9 the value is 3, but 3 points, restricted to 3 points. Okay, now also note here that we don't have negative numbers for the x-axis, x value, and we don't have negative numbers for y. So we should draw our axes so that we don't waste space. So for example, if I draw my axis like this, my graph is only going to be in this quadrant, so in the first quadrant, right? In the first quadrant, all this space is kind of wasted. So we shouldn't draw the axes like that. We should draw the axes in a way so that we waste the least space. So draw them like this and like that. Actually, if I can go more to the right, that will be great, because we need to jump from 1 to 4. Well, yeah. Okay, so at 1, 2, and if you want, you can put a 3 here. This is y-axis and this is the x-axis. Okay, so on the x-axis, 1, 2, 3, 4, 5, 6, and so on. So then I plot the points. So I have 0, 0, 1, 1, and that at 4, when x is 4, y is 2. And now we join the points again, not by straight lines. This is what you have to remember. You cannot be doing this. That is not the correct graph. Okay, so what should you do? You should draw a smooth curve passing through. And also, it shouldn't stop at this point. It should keep going a little bit to show the reader or whoever is looking at it or going to look at your graph, show them that it is going on and on. Because if you only draw up till here, this solid point here shows that the graph is stopping here, which it is not. So that's how we graph the function. Okay. So if you want, again, I didn't do it before, but you can write these points if you want. But they are already shown in the table. So even if you don't put them here, that's fine, because your table is showing them. So this is how we graph the function. Okay, I will stop here and show you the graphs of other functions, and then we will talk about how to graph piecewise function in the next video.